Welcome everyone, I am Alan Delisle. I'm the Technical Sales Coordinator here at Phillips Precision. I want to say thank you so much for checking out our Part Furniture live stream. Now this is a live stream just for you guys. This is not for end users. This is just for distributors and our partners exclusively. We want to say thank you so much for being part of our tribe and working so hard out there. The purpose of getting together on this is to convey a simple message and the benefits of going with modular fixturing and fixturing for your laser marking machines, and really how companies are working at a deficit by not using this type of fixturing. We've come a long way in manufacturing where there has been so much focus on the shop floor and helping to improve the shop floor speeds with technology for fixturing, work holding, cutting technology, coolants and lubricants, and even in the software and everything too. So now it's about time for us to bring that same drive and that same passion and improvement to the metrology labs. And I know that many of you have spent time in the metrology labs, many of you haven't. And if you are selling standard industrial equipment such as cutting tools and abrasives and things like that, and you haven't spent much time in the metrology lab, that's okay. Don't get discouraged. Don't get nervous about it. We are here to help you cross that threshold, and that's kind of what the whole purpose of this was. You got to understand that we're in the midst of barreling towards the fourth industrial revolution, where automated work cells, robotic arms, unmanned automated work is really the name of the game. And that's, it's going to continue to happen as we continue to improve with technology, but also as we continue to struggle finding more and more replacement employees to take over the jobs that are being left by retirement that are just so prevalent. We call it the silver tsunami. It's actually just kind of a crippling amount of people that are of retirement age that are all retiring all at the same time. So products and services and techniques like this are the way that we're fighting back and helping companies position for the next generation. So with a quick swap fixture like you would achieve with Inspection Arsenal and Lock and Load or Open Site would make it easy for less skilled operators to be able to inspect their own parts and do that work. So you could have a single inspector program the machines, develop the complexities in the fixturing, get the fixture set up. Sometimes we'll even put barcodes on the sides of fixtures so that operators can scan a job traveler and then scan the fixture to make sure that they are indeed holding the right one and loading up the correct fixture. There could be mirrored fixtures. There could be fixtures that are very close in design because you have multiple parts that have very similar features. So in order to break away from that, the mistakes that could be made on there, we'll put barcodes on those types of fixtures to help pass that off to an operator. Now these products and services techniques, they really exist to improve the entire production pipeline. We need to get away from the mindset that inspection is this non-value added necessary evil and start to understand that the inspection process and your quality process is really where the value and the quality in your entire work and the entire process comes from. That's where that stems from. And everybody seems to be suffering the same bottlenecks in their metrology lab, so you can open up those bottlenecks and alleviate much of the cost that could be associated, and sometimes crippling costs that could be associated with a complex inspection process. One thing I do want to get right out in the open is that while the inspection clamps and fixtures, they don't really wear out, this is actually the most consumable fixturing system on the market for the inspection lab today. So many customers will be reordering and placing additional orders for ancillary products and additional accessories, more plates as their production grows. And as they're building fixtures for repeat jobs, those fixtures are going to sit on the shelf and they're going to need more fixturing for more jobs in the future. So regardless of whether they are inspecting onesie twosies or prototypes or long runs of productions and repeat work, going with a modular design and getting parts on and off their machines faster is going to be the utmost value to them. Because profits are in the speed of the swap. We know that on the CNC machines on the shop floor. If you can get product in and out of that machine faster and eliminate that downtime, that's where you're going to start to see your bottom line grow. And ultimately, no matter how fast you're making parts on the shop floor, if you've got a bottleneck in inspection or things are getting jammed up in assembly or jammed up in laser marking, there really was no point in making them any faster on the shop floor because your entire process is still slow because of other areas, right? So if we can help to break the bottlenecks and help open up that workflow, you're just going to be delivering perfect parts that much faster. And so some of you may be already aware of how CMM works or how a vision system works. Some of you may be brand new to it. To make it as easy as possible to understand, a CMM machine uses a touch probe to touch off on the part and take the locational dimensions of that part in relation to datum points set on the part in your program. Whereas vision uses a camera and a lens to locate those parts. Now, a vision system is usually faster. However, it's tricky to get the three-dimensional imagery or three-dimensional features on any given part with just a camera. So that's where your CMM would come in. And then you have multi-sensor machines and stuff as well. Although getting into custom fixture design later, Victor will talk a little bit about some first surface mirrors that we use in our custom designs for vision systems so that you can take those three-dimensional points all at once. But either way, regardless of whether you're using a CMM or a vision system, fixturing is going to be necessary to hold your parts, to access certain features, to access the critical features that are being inspected, to get a clear line of sight for your camera to see these features that it needs to see, or for getting a touch probe in there unrestricted or without shaking out. So it's very important to fixture your products properly. And as I said before, it's also very important to fixture properly as to not deform or distort your parts when they're on the machine, because that can be detrimental. It's very common to have an operator using clamps and vices from the shop floor, and they are tightening up these parts and they're either moving in the fixture or they're tightening them too tight and they're distorting the parts, making parts bad right on the machine. So the machine that they're trying to inspect it with, they're actually making it bad with. And they end up with a whole bin full of bad parts, and they know they're good, but they can't prove that they're good because they're manipulating those parts and they're distorting those parts with their fixturing. So these new machines are getting faster, they're getting more accurate, they're getting easier to operate. Many of these machines can actually measure down to single-digit microns, which is literally about a 40th of the width of one of our hair. So, I mean, you're talking some serious machines here. So it's clear that these machines are quite valuable. I mean, the technology allows you to pick up multiple features on three-dimensional parts all in one go, and very accurately, very efficiently, and the repeatability is staggering. But not without proper fixturing. So no matter what you do and how great the machine is, if you're spending countless hours trying to develop a fixture or build a fixture, tearing fixtures down and rebuilding fixtures, that's all downtime that begins to diminish the value of the machine, right? So anywhere you can eliminate that downtime, you are going to increase the value of the machine and increase the value of that process. Again, profit is in the speed of the swap, right? We're here to deliver perfect parts faster. You know, and your one-piece grid plates, they are yesterday's news. They are old school, they are outdated. You know, your inspectors are literally stuck working on one piece at a time. And depending on how many hands you have in the inspection lab, every time that fixture is built, it can be built a little bit different. You may get different results from your inspection process every single time. And that's something that we want to try to eliminate. So you can build your fixture one time, it stays built, it doesn't have to be changed, it doesn't have to be swapped over. It can stay built on a piece of fixture or on a grid plate that can be loaded onto the machine many times even faster than it takes to pull the program up in the computer system. And that's not an exaggeration. So just remember the takeaways. For modular quick swap fixturing, you're increasing the bottom line by eliminating downtime. You are eliminating the time that the machine is not running, eliminating the downtime that the machines on the shop floor are not running. You are gathering that inspection data much faster, catching mistakes and errors much faster, so you're not running at risk, you're not making bad parts without knowing it, and you are really protecting your company's reputation on being able to make good parts and deliver them on time. Speed up the ROI on all of your machines by increasing the amount of uptime that they are, the amount of time that they're actually running. You can increase the employee morale by taking stress off of them, by giving them an opportunity to build fixtures much faster. We have CAD models available for all of our products. So at the same time that you're developing the fixture for the shop floor, the same time that you're developing the part, you could be developing a inspection fixture. So when that part comes off the shop floor into the lab, it's not an afterthought. You already have a concept or a design ready, and in many cases you could even have a full fixture already pre-built and ready and waiting for that part. So you get that part, and if you're in the middle of a long run, you can remove the fixture you're working on, pause that program, and go ahead and load up your next one and give that data back to the shop floor, and then go ahead and pick up where you left off on the first project that you were working on. So something to keep in mind, as you can see here, there's really no right or wrong way to set up your machine. It's like an erector set, so you're limited really by your own creativity. We keep a rail on the X and Y axis of the machine, and we use double-sided tape, so you can actually stick it right outside the work envelope, and we don't lose any of the area and the measurement area of the machine. And this gives us an immense amount of flexibility to set up jobs the most efficient way possible. So we also have customers who run a series of rails across the entire granite, and where they can load up their fixtures wherever they need them to go. And in many cases, you could load up multiple parts on the machine and run a whole string of parts and run a routine, and that will help you to automate those processes too. You could set up parts and run them out, lights out. And from there, you'll just need to help your customers just decide what plates they need to accommodate the workpiece and not the machine. There's never any reason to cover the entire granite surface. You could easily put a fixture on one plate over here, and then on the opposite end of the machine you could put another fixture, and you could span your part right across the entire machine, having all bare granite right in the middle. So if you have any questions on all this stuff, please feel free to lean on us. We're here for you all the time to answer any technical questions that you have and to help guide you through this. Next up, I'd like to introduce to you the inventor of the inspection arsenal system and the owner and president here at Phillips Precision, Mr. Steve Phillips.
25 years ago, my wife and I were working for big companies, and we got a little burnt out on working for other people and decided to go off on our own to, give it a go and live the American dream and kind of call our own shots and run things the way we saw fit, which seemed to be a pretty good idea. And so in the beginning, we started off by doing rapid prototyping, a lot of 3D machining. I had the shop set up, so it was just a one-man show. I had the shop set up with cameras on the computer, and I'd get the machines running, and I'd get to the point where I could go home, have supper, spend a little time with the kids, keep an eye on the machines. And one of the problems that we had was parts would rip out of the machine. If you're pushing parts a little too hard, the parts would pop out of the vise or your fixture, and we kept having to slow our feeds and speeds down to compensate for the clamps that were available at the time. And so after about an hour worth of design, another hour or so to come up with a working prototype, we had our very first pit bull clamp. And my brother and I actually kind of played around with the clamp, and funny story there, I kept telling him, go a little faster, and my brother was like, I don't know, I don't want it to blow up in my face. I'm like, push it. And so he pushed it, and as fast as he possibly could to try to get it to come out, because he was mad at me for barking at him, and it stayed right there. And at that point, we realized we had a winner. So what cost me about an hour of my time, maybe a few hours to kind of tweak things, it cost my wife, Kathy, a number of years getting the patent written and getting that all going. That was probably the harder part. But that was kind of the early years, and eventually we ended up selling that off to Mighty Bite. And in the meantime, we got our first CMM, and it's got just a plain granite plate with some bolt holes in it. And one of the very first questions I asked the tech, I said, well, how do people hold parts for production? How do you load this machine up? And you can't use hot glue and sticky tape, double-sided tape for everything. What do you do? And he said, well, they have plates out there. They're really expensive for what they are. Most people make their own once they get a load of the price. And you'd take your fixture components and you'd screw them into certain locations, and then when you're done, you'd have to break it all down. You'd have to put all your components away, and then the job would come back a month later, and now you have to set it all back up again. And I'm a machinist. I'm out in the shop floor. I'm programming jobs, making fixtures, and in the machine shop, we make fixtures. When we're done, we put them away. When next time the job comes back, you take the part, you put it back in the fixture, and you're running parts, very quickly and efficiently. So my thought was, well, why would we treat our CMM differently than we would our milling machine? So now that we have this new product, the inspection arsenal, we have this nice rail and plate system, the inspector was able to switch over jobs faster. I noticed the line of machinists going into the inspection department got shorter. You know, a lot of those jobs that we had, we just left them on a fixture plate dedicated for that particular part. Those fixtures were on the shelf, ready and waiting. So rather than having the inspector playing battleship, you know, building a fixture up and then tearing it down and putting everything away, you know, take the fixture, plug it into the rail, and get those parts inspected right away, get the feedback back out onto the shop floor. Machines are running more often. They're not sitting there idle waiting for the first article inspection. It literally went from, you know, what could have been a half hour to an hour, even several hours, could be just a few minutes, which was incredible. And so we saw the value in it. Our customers saw the value in it, and it just took off. And then it wasn't that much longer after that where we had our laser marking system. We started using it in our own because it just seemed like a natural fit for the product, and that was a home run. And we had a bunch of customers that implemented it in their own shops for getting laser work turned over quickly and efficiently. It's such an easy sale. You go in, and the first thing you ask, and you go into almost any shop, and you'll ask them, where's your biggest bottleneck? And they're going to say, oh, it's the inspection. The inspector, it takes them too long, this and that, the other thing. And you take a look at the CMM, and if it's just a plain granite plate, it's a no-brainer. You get that rail on the plate, and you get your qual sphere on and off the machine, park that out of the way, get just a few different fixtures on and off the machine within, you know, just a few minutes, and you'll see a huge improvement in production, and it's just an easy sell. Whatever we have on the shelf, we can, you know, pull it off and ship today. You know, if it's in our catalog, more than likely we have it in stock. So anytime we can use standard product, we will. But there are times where, you know, you maybe have to modify product. That doesn't take very long, so you know, that might be a day or two, maybe a week, depending on how sophisticated it needs to be. But there's a lot of times they're going to require a custom fixture. There's almost no getting around some of them. They're just because they have to have clocking features and they have little tiny details. One of our specialties is designing custom fixtures for products like that. And Victor Rinaldi is our engineer, and he can definitely get into a lot more detail in that regard.
Hello everyone, my name is Victor Rinaldi, and I am the product design engineer here at Philips Precision. A bit about myself first. I'm a mechanical engineer, and my background, it's been pretty much on manufacturing. In other words, I cut my teeth out on the floor, so I understand how manufacturing is done. That gives me an advantage when I design anything from components to regular fixture to custom fixtures. The understanding of how to approach the machining helps me design the fixtures and the component the correct way. With that said, let's discuss a little bit about designing and thinking about how to design custom fixtures. There are many considerations about designing custom fixtures, and I'm going to go through and maybe ramble a little bit here and there, but I'm going to bring everything together at the end, and hopefully it's going to make some sense. So the most important thing is understanding the requirement that the customer is asking. In other words, what type of part is being inspected, what kind of dimension are being inspected and how they want to hold that component in the fixture itself. In other words, we need to understand that we have a solid model that is released and available, a print that goes with it, and the dimension on the print, they need to be marked correctly. In other words, we need to understand what the datums are, what the tolerances are, what the critical to fit or critical to function dimensions are, and again, how the customer wants to hold that particular part, if it is vertical, horizontal, or any other position. In addition to that, we also have to have consideration on which type of equipment that part is being inspected. The approach is very similar, regardless if it is a vision system or a CMM. So what we need to understand is, if it is a vision system, does that vision system, does it have tactile capabilities? And does the customer want to use the tactile, the probing, in order to inspect some of the dimension then you have to inspect on that part. On the other hand, on the CMM, we need to understand if the CMM head is a fixed head, a static head, just with several different probes, straight down, star, L, or whatever else, or if there is just a straight probe down and the head is an articulating head, therefore giving the customer the capability of rotating that head and getting around the part as they please. When I create a fixture for vision, obviously it is designed on top of a polycarbonate plate, and there is a post or a device holding that part in place. Once the part is in place and you take a view from the top of the part, you should not be able to see that post or device, and the silhouette of the part should be completely free. In fact, in many cases, the plate itself, it is relieved to make sure that the silhouette of the part is not on top of the plastic itself, in order to provide the most amount of light without any scattering whatsoever. Many times a part can be just put on top of the post or the device with no retainer, because it's purely because the approach that the customer is taking is purely vision. However, if the customer is using vision and tactile, now we need to create a sort of a retainer to ensure that that part does not move when the probe is going to be touching the part. The most important part when I design and when I create a fixture is to ensure that I use surfaces that are available to me that are not going to be inspected. However, if I must use datums, then I use datums by holding the part in several points, usually 3, but depending on the geometry of the part, they can be more than 3. And then using either a spring-loaded device or a magnetized device to create enough downforce on the part so that the part does not move. Now, with that said, we need to stay to a minimum amount, and this is also dependent. It's also dependent on the part geometry. If the part geometry is very robust, there are no issues. But if the part is very flimsy, then there will be some issues there, because you don't want to be basically applying too much force or pressure on the part to distort the part. Generally, a probe from a CMM or from a vision system will probably be in the vicinity, would probably exert about 5 to 8 grams of force, which would be 0.08 give and take newtons on the part. One of our goals is to make sure that when we retain the part, if the part is robust, then we measure it with a force gauge, and we want to make sure that we don't dislodge that part from the fixture with at least 50 to 100 grams. So basically 1/2 to 1 Newton of force. Okay, and this applies for both CMM and vision systems. And it's also based on the size of the part. If we have a tiny part, obviously the force is going to be much smaller. If we have a part that is 20 by 20 and it's plastic and it's bowed and needs to be constrained, then that is a different approach. With that said, let's talk about a little bit of the design of the post. Basically, when we start designing for a fixture, we just don't jump into the CAD and start designing something. Usually the design reveals itself. You create some sketches on some paper, and then you start poking holes in that theory, and you start to understanding and visualizing if you can get around the part and check everything else. And then you create an assembly on the CAD, and with the part on site, you begin generating the fixture around the part. That is the same process regardless if it is vision or is CMM. The only difference there is depending on the size of the part. Again, if we have very large parts, the forces applied to maintain that part in location are greater than if we have a very small part. The goal, regardless if it is a vision fixture or a CMM fixture, is to have repeatability and reproducibility. Now, we all know that repeatability is when one operator can repeat the same process of mounting that part on the fixture and applying the retainer, either spring-loaded or magnetized, or sometime manually applied with a screw on the part in rare cases, and that depends again on the size of the part. The goal is to have a retainer that is totally toolless, so that it doesn't matter who the operator is, the repeatability on mounting and dismounting that part and placing the retainer or twisting the clamp that is spring-loaded is exactly the same all the time. So we remove that possibility of error away, and that is repeatability. When it comes to reproducibility, the reproducibility talks about can this entire process be reproduced by someone else. And generally, that is a study that is done by the inspection department of where this fixture is going to go and is going to land. That is something that perhaps is part of their validation or part of their IQ, OQ, PQ validation. But we are always here to support our customer on all the type of questions that they have, because we need to understand if these fixtures that we are creating are being used to inspect just a few parts along the way, to make sure that manufacturing is progressing just right, or if they're being used to create GR&R or any other type of validation, or if all the data is going to then eventually be studied as a distribution of percentages. Let's say the customer says we want our GR&R to be less than 10 or less than 5%. With that said, let's regress back to the design of the fixture itself. So in mind, we have to keep customer requirements. What are the datums? What are the dimensions that need to be checked? In many cases, I have customers saying that for initial validation, they need to inspect all the dimension, including the one in parentheses that, as we all know, are references dimension. Once the initial validation is done, then they go into a GR&R, and there are only a number of dimensions. Usually these dimensions are ovalized or are marked in the print in any other way as critical to fit or critical to function. Once we have datum, once we have the dimension, then we can create the fixture, the post, the device that is going to practically hold this part. And this is valid both for vision and for CMM. Additional consideration for when a fixture is being designed is the type of part that is being mounted, meaning is this a metal part, a plastic part, casting? That makes a difference how you approach the design and how you're going to hold the part. There are many type of parts, and some parts are IP protected, other parts are ITAR. But here at Philips Precision, we are more than willing to sign any NDA, or we are not, by the way, so then we are clear, then we are not ITAR certified, but we do work with customers that are not ITAR certified, and we are able to create a design separate to the part itself, and then provide a design to them, and they do the fitting, in a sense, of the fixture, of the part on top of the fixture. Other consideration is this going to be a one-up or is going to be a several-up? For instance, if a customer has a mold and is a 32-up and they have a machine, let's say an OI 543, that when the fixture is designed can only accept a 16-up type of fixture, then if they're running a GR&R, then the customer will need fixture 1 and fixture 2, where they will inspect 16 parts first, and then the other 16 parts for a total of 32 for the first shot of the mold. Then they're creating these parts of these devices. So that's an additional consideration to the approach of how we do fixturing. We have many customers that they do a one-up fixture or a two-up fixture because it's a test mold, and they want to make sure that all the dimensions are right. And then when they go to a production mold, let's say a 12-up or a 96-up, or in cases we work to molds and we're 288-up, then we create these kind of large or monstrous type of fixture to hold all the shots that the molding machine provide for that particular part.
I would like to demonstrate my approach in the ideation and design of a fixture. This one is an 8-up for this particular part. This part is a flexible part, and it's two type of plastic. The brown one is not as flexible, but it's still bowie. And the green part is a very soft silicone type of plastic. Therefore, this part, it's not flat, but it needs to be constrained in order to measure the diameters of the hubs at several heights, and also the distance from center to center, which is a basic dimension. And this is a quick view of the print. And as you can see on the top right over here, we have different height and different diameters that need to be checked. And over here we have 7 times 9 millimeter. So from center to center, for the last one to the first one, it's 63 millimeter. Now in this case, this is going to be vision, and we are going to be able to check from the top. We can check basic dimension going across from hub to hub. And from the side, we're going to be using a mirror, and we can pick up the center line and check those dimensions as well. So let's get moving here. As far as the parts are concerned, so I designed a small plate, as you can see. It looks like a lot like Swiss cheese, but again, it's needed to hold this part. The deeper pocket will hold basically a mirror post, and this small pocket will hold the part. The next part is basically a clamp that is going to be screwed on top of the main plate per se, with some slots in the bottom, will allow us to move the part in and clock it or stop it at the bottom of the slot. After that, we have a mirror post, and after that, we have an end post. Then it's needed in order for the camera to see from the last mirror and not to have any distortion or not to focus outside the range of the camera. So with that said, let's go to the actual assembly here. Let me see, let me bring this up. This is the actual assembly without parts. So we have the bottom plate, then we have the top plate, which I call the retainer, and then we have the mirror blocks with the mirrors within that pocket. And we have at the end a block that will allow the camera to focus through the mirror but no go beyond this surface. In the other case, next to it, the back part of the mirror is, in a sense, the backstop for the camera when it focuses on the mirror. Now, this fixture will allow us to basically insert or slide the part into the slot. It will stop at the end on these two surfaces, which is the same surface, therefore straightening the part and allowing us to see the part from the bottom, get the total length, get the width, and get actually the basic dimension, from hub to hub, and also look through the mirror and see the diameter of various heights. Let's go take a look at the assembled fixture. And this is the assembled fixture. As you can see, the part is inserted into the slot. I'm going to quickly hide the clamp. As you can see, the part slides into the slot, stops at the end, and the clamp that is on top, it's static, it's not removable. So basically the part, it's slid into the slot all the way to the end. And now I am going to hide this last block for a moment, so you would have an idea that when the camera focuses on that mirror, the camera will be able to pick up all the diameters needed at different heights as per the requirement of the print. And let me bring that back for a second. When the camera focuses from the top, the camera can get the width in 3 different places and the length of the part in 2 different places, and also the dimension, which is 9 millimeter from center to center of each hub for a total of 63 millimeter. And that is a very basic approach of the process of taking a print and the requirement from the customer. In this case, it was the part needs to be constrained, it needs to be stopped, and we need to use a mirror to get dimensions from the side and the camera to get dimension from the top.
I also want to discuss about the process. How do we get there? Like, for instance, if a customer or representative brings a part and say, I need a quote for this part. So generally, we get a model in a print. We have a quick meeting to establish the base requirements. And then at that point, we put our experience together and come up with a number that we call a budgetary number. The budgetary number can be looked at as, in a sense, as an NTE, and not to exceed cost. But generally, that is actually taken as a cost that has a plus or minus 20% chance of moving. That helps our customer to understand, to basically create a target and say, this is your budgetary. If you are within this budget for creating fixture, for creating parts, then we can move forward to the next step, and that would be to create a formal proposal. When we create a formal proposal, we don't have anything in a sense, we are still flying blind because we don't have any models, we don't have anything. We just have basic requirements, model of the part, and we have prints of the parts with the dimension that we have to inspect. At that point, we compare and contrast with other older fixtures that were designed, and we try our best to create a formal quote based on that. Once that is accepted by the customer, let's say then we have 5 different fixtures then we need to create. Then our job is to let the customer choose one of the parts, and we create a fixture around that part. And then we have another meeting to discuss, in a sense, that fixture to see if we are all on the same page as far as how is the approach of the inspection of the part. Once all the thumbs are up, then we create all the fixture. We have a final meeting for basically approving all the parts, and from there we go to manufacturing. The whole process from start to end, based on the complexity of the geometry and the quantity of the part, can vary anywhere from 4 weeks to as many as 10 to 12 weeks. We do large and small fixture for many clients of ours, clients like Tesla and Boeing and General Electric and MSI Viking. So a job is never too small, but at the same time is never too large. We will tackle if we have the capability of manufacturing those components, we will tackle that job. So just as a recap, we need information from the customer, and that is in the form of solid modeling, step files preferably, or SolidWorks. We need drawings with all the established dimensions that are critical to fit or function. We need to understand if this is a vision with or without probing capability, and we need to understand if this is a CMM with or without articulating head. Then we need to understand how many ups, meaning how many of these components would the customer like to inspect? Is it one at a time, 2, 3, 10, 20? So that will gives us the idea of the size of the fixture, and we will find out pretty soon if that fixture will fit on whatever equipment that they have. Many times it does, many times it doesn't, and we have to split it into 2 different batches. Once we get to that point, we basically create a budgetary quote. We provide the budgetary quote. If the customer's budget is within that number, we'll get together and decide which part they would like to see as a demo. We create a rough but fairly well finished model around that, and then we have a meeting and we review and discuss that model to ensure that both sides are thinking on the same wavelength, and we're going to take the same approach, meaning not the approach that we think is best. We can make suggestion, but the approach that the customer inspection department prefers. At that point, we create a formal quote, we receive a PO, we generate all the necessary models. We have a final design review to get approval. Once we get approval, we generate drawing and we move that into manufacturing.